Welcome back to my online platform. Kindly subscribe to this channel. Kindly subscribe to this channel. We are going to discuss about connected spaces in topology. Connected spaces in topology. So this is an introduction. So in simple terms, for something to be connected, it cannot be it can be separated by maybe some means, but if something is connected, then it has no separation. For example, this interval in R, the interval from 0 to 1, it's connected. However, it can be separated, but we all agree that the interval is connected. Yes. Also, a closed interval is connected. An empty set is I want to say that it is vacuously connected. Yes, an empty set. Because can you separate an empty set? It's connected. You cannot form its separation. So basically, we are going to define connectedness in this way. So we are going to let this be a topological space. So X is connected. Allow me to use that abbreviation. X is connected if X cannot be expressed as a union. If X cannot be expressed as a union, if X cannot be expressed as a union of two non-empty, open, not be expressed as a union of two non-empty, open, disjoint, union of two non-empty, open, disjoint subsets. What are we trying to mean there? There are fundamentally a few things to take note of. We have non-empty. X cannot be expressed as a union of two non-empty, open, disjoint, and maybe distinct subsets. So this implies that X, to be connected, X shouldn't be equal to the union of sets A and B, where A and B are open in X, A and B are open in X, A and B are disjoint, are different, are distinct, they are distinct sets, and their intersection is an empty set. Which other one? An empty, and also A and B shouldn't be empty sets. So it simply means that we have two sets, A and B. This is my A, this is B. So X shouldn't be expressed as a union. X shouldn't be expressed as a union of these sets. X shouldn't be expressed as a union of these sets here. It shouldn't be expressed as a union of these sets. If it is connected, X shouldn't be separated in simple terms. It shouldn't be expressed as a union of disjoint, open, non-empty subsets of X. So if X cannot be expressed in that form, then X is connected. So we are going to define a separation of X. So we want to define a separation. This is a definition for connectedness. Connectedness of a topological space. So we are going now to define definition separation of a topological space X. So let X be a topological space. Let X be a topological space. A separation of let us say the pair A B, the pair A and B, the pair is a separation. That pair is a separation. The separation of X if let me say a pair is a separation of X if it forms the separation of X if let me call it a pair of open sets. A pair of open sets A and B is a separation of X if A and B are non-empty sets. A and B are disjoint, their intersection is empty, the intersection is empty, and X is equal to A union B. So a pair of open sets is a separate or forms a separation of X if those two sets are non-empty, their intersection is empty, they are actually disjoint, and X is equal to this union. It's like now we are saying that X is equal to A, this is my A, and this is my B. The union of these two sets, which are non-empty, they have things in here, also in here, and they are disjoint. They are not meeting. So this is a separation. This is a separation of X. So we shall say that X is so if something is not connected, then it's disconnected. X is disconnected if it has a separation. X is disconnected if it has a separation. If it has a separation A union B, it has a separation A union B, where A and B are non-empty, disjoint, if it has a separation, these A and B are non-empty, disjoint sets. Yeah. So that is the definition of disconnectedness. Similarly, we can also say that X is connected if it has no separation. Yeah. X is connected if it has no separation. As in X having no separation, that means X cannot be expressed as a union of two non-empty, open, disjoint sets. Yeah. So in the next tutorial, we are going to look at characterization of connectedness in the topological space.